Chapter 14, Gases, Part 2. Atmospheric pressure. Atmospheric pressure is caused by the weight of air, just as water pressure is caused by the weight of water. The atmosphere, much like water in lake, exerts pressure. We are so familiar to the invisible air around us that we sometimes forget it has a weight. Please note, you do not notice the weight of a bag of water while you are submerged in water. Similarly, you do not notice the weight of air as you walk around in it. So, atmosphere is an ocean of air. It exerts pressure on Earth, and this pressure, the famous hemisphere experiment of Otto von Guericke at year 1654 showed the large magnitude of the atmospheric pressure. And in this experiment, Guericke managed to evacuate the two hemispheres and seal them together. So the pressure is only the atmospheric pressures. Then he has 16 horses, 8 in each side of the hemisphere, and they try to pull them apart to separate them with difficulty. And this is showed that the large magnitude of the atmospheric pressure. By the way, Otto von Guericke, he's the one which is the inventors of the vacuum pump. So let us talk about fact about atmospheric pressure. It's caused by weight of air. It varies from one locality to another. It is not uniform. Measurements are used to predict weather condition, which the air is always moved from high pressure to lower pressure. Let us try to evaluate the atmospheric pressure, the value of the atmospheric pressure. We know that the density of air changes with temperatures. At sea level, 1 meter cube of air at 20 Celsius has a mass of about 1.2 kilogram. If we calculate the number of cubic meters in your room, multiplied by density 1.2 kilogram per meter cube, you shall have the mass of air in your room. Now, let us consider a super long hollow bamboo ball that reached up through the atmosphere for 30 kilometers. If the inside cross-section area of the ball is 1 centimeter and the density of air inside the ball matches the density of air outside, the enclosed mass of air would be about 1 kilogram. The weight of this much air is about 10 Newton. Simply, mass multiplied by the gravity, it will give you 10 Newton. The weight is 10 Newtons. Air pressure at the bottom of the bamboo ball would be then about 10 Newton per square centimeter. There are 10,000 square centimeters in 1 square meter, as we know. So a column of air, 1 meter square in cross-section, that extends up through the atmosphere, has a mass of about 10,000 kilogram. This 10,000 kilogram weight 100 Newton, 100,000 Newton, 10 to the power 5 Newton. So the weight produces a pressure of 100,000 Newton per square meter, or equivalently 100,000 Pascal, or 100 kilopascal. More exactly, the average atmospheric pressure at the sea level is about 101.3 kilopascal, 101.3 kilopascal. The pressure of the atmosphere is not uniform. There are variations in the atmospheric pressure at one locality due to moving air currents and storms. Now, question about how many kilograms of air occupy a classroom that has 200 square meter floor area and 4 meter high. Answer is 960 kilograms. The detail of the answers: if the volume of air is 200 meters square multiplied by the height, which is 4 meters, this will give us 800 meter cube. Each cubic meter of air had a mass of about 1.2 kilogram. So 800 meter cube multiplied by the density, which is 1.2 kilogram per meter cube, this will give us 960 kilogram, which is about ton. Now, conceptual question: what causes atmospheric pressure?